Okay, we're back with copper standards for gigabit Ethernet. Initially, early 90s, if you will, the concept of running gigabit over twisted pair was just like, you gotta be kidding me. But as better quality cabling connectors was built, it was popular or possible to have gigabit over twisted pair cabling. Category 5 was put to use, but they found better construction, advanced cable construction. Category 5E, 6, augmented 6, 7 now has been able to do gigabit and beyond for that. So 1000 base T, standard IEEE 802.3AB, completed in 99, was able to kind of define gigabit over twisted pair cabling. Required 8-pin modular jacks again, RG45, distance limit 100 meters, same start topology, using all 4 pairs of the wire, if you will, all 8 pins. So what we kind of consider norm today, they were specifying roughly 15 years ago. They remind us that network speeds go up by a factor of 10 about every 5 years. So the jump to gigabit happened faster than they thought. Right now, we're all pretty much using gigabit to desktop. So, we might be looking at 10 gig to desktop in another 5-10 years ourselves. 1000 base CX, this is not very common. This was another standard set is using using coax, if you will, twin X coax for copper. For copper connection in your closet. They defined the standard using this kind of the coax that you would have used for thin net, using 2 conductors in here. And the idea was this could be used for closet connections. But this was not very well, or I should say not widely adopted. You don't see these ports on anything. So most things kind of lean towards the direction of 1000 base T, but this was another standard set aside for closet connections. They mentioned ATM at this point. ATM, kind of a WAN connection, if you will. You don't see it too much in LAN, but they did specify standards for ATM for using, I should say, gigabit standards for an ATM using copper. So this is the part that you would kind of recognize down here, 50 meg, 155 meg. These were kind of the ATM copper cabling, if you will. Then we needed to move into the fiber for ATM. Standard 4 gigabit 568C, again, shows everything that we need to, or defines everything we need to for cabling a building for gigabit. 568C has standards set aside for fiber as well, C3 for copper, C2 by the way. C3 for fiber allows the use of your step index and your graded index multi-mode fiber, 62.5, 125, and your 50 graded index 150, 125 multi-mode fiber, as well as single mode fiber for horizontal and backbone cabling. They said a link budget, 100 meter horizontal cable link is modest. 850 nanometer max cable attenuation, they define that for you. Roughly translates to about 0.34 decibels for a 90 meter horizontal run. Losses at the connectors are much more significant for all this. Link losses are typically in the 0.15 decibel down to, or 0.15 to 0.2 decibel for each of the connectors. So all the connections are usually well within the specified standards for. In most applications, gigabit Ethernet uses backbone tech. Well, we're starting to see today 10 gig is pretty much the backbone. All right, 62.5, 125 limited to a range of 250 meters. 50, 125 limited to a range of 500 meters. As we jump up to the 1300 nanometers, we can get greater distances than 500 meters. Okay. Connectors for this one, we've mentioned this before. When we went from the earlier standards, 568, B to C, they took the unusual step of not recommending a specific type of connector. That allowed the doors to kind of go open for technological advancement. All they did was specify that the connector had to be of certain performance level or better. Actually, I think I'll pull my standard up here real quick. Yeah, I just happen to have that. If I go to our 568C3, that's on page 53. Let me pop that guy up real quick. If I go to C3, in here I should have, oops, I actually jumped too far. Back up just a little bit. There we go, there's C3. Fiber optic connector is on page 51. If I zoom in and take a look, what it tells me is no specified connector needs to be used, if you will. I don't need to use a specific type of connector for my fiber connections, and that opened the door for some technological advancements. Minimum standard considered usable for gigabit is category 5. Gigabit rates require all 4 pairs for that one. It's barely able to keep up, but it does do it. The result from this was your enhanced levels, your 5E, those sorts of things. With your 5E, most people started adopting this immediately because it could handle gigabit to, again, copper link gigabit to the desktop, if you will. The most problem they had with this was your crosstalk, and this is just reminding you, crosstalk is the phenomenon of a signal transmitter on one circuit trying to jump or affect the signal in a nearby circuit or channel. This would be like hearing somebody else's phone call. I'm hearing their signal on my wire. Well, a cable with a low far-end crosstalk or near-end crosstalk will perform better at all frequencies. So category 5 construction was engineered to try to minimize that. That's where the 5E comes from. Resistance, capacitance, inductance of your copper wires act to reduce the amplitude of the signal, weaken it. Attenuation in a cable is frequency dependent. Higher frequency, the more attenuation. Again, as we start moving gigabit, 10 gigabit, those higher frequency ranges that you're using are going to attenuate quicker. A problem as we're starting to increase the frequency of the data that we're moving through. Advanced cables, 5Es, 6, augmented 6, maintain very tight geometry of the cable to minimize all this. That's, we talked about the internal structure of the cable changing. Here, reminding you near-end crosstalk, that's the interference caused at kind of the near end of your testing. Meanwhile, the far end is away from you, the other end of where the link that you're testing. Let me back up here really quick. Crosstalk is generally computed as a ratio of the voltage between a test signal and the induced crosstalk signal. So a next measurement should be high, indicating that the signal has not jumped into a nearby wire and is resisting the effect of this interference, this noise, if you will. Another measurement you run into as we start getting to gigabit higher level testing is your attenuation to crosstalk ratio. Attenuation crosstalk, a ratio of the attenuated signal to near-end crosstalk. It's a factor in determining how far a signal can be transferred in any given medium. Well, I want to actually have, I think I have in here an example. Where do I have this? Here we go. Oops. I want to have several decibels for proper performance. So the ACR must be at least several decibels. The difference between the attenuation and the noise. I need some distance between there as I'm doing my measurements. If those are really close, I can have potential errors from the noise overtaking my signal being my signal weakening over time. If my signal weakens too much, the noise can overwhelm it. So I need some difference between those two numbers. I still need a strong signal and less noise, if you will. And that's why they show the ratio between the two. 5E was kind of denoted as gigabit. As we moved on from there, category 6, augmented 6, 7, 8. 8 is on the horizon, believe it or not. These have been able to kind of advance our performance 10 gig, and looking at down the road, they're looking at 40 gig and so forth across copper. So these have been able to, the structure of our cabling changing has been able to open up some more possibilities for more bandwidth down the road. When we moved, Category 5 had a lot of problems with the connectors, lots of interference and lots of crosstalk possibility. As we moved into Category 6 connectors, they changed the style a little bit. If I look at a traditional Category 5, 5.5E connector, if you will, one-piece design, the wires are fed into the channels like we're used to dealing with, all 8 wires into their little channels and terminated. Well, that flattens all the wires out and I get untwist here. Well, as I move into Category 6, the design has changed. The wire pairs are fed in, and if you see, they're almost like they're angled. Well, they're twisted up to the point of termination. So a lot less wire untwist, a lot less chance for interference, a lot less chance for near and crosstalk and that sort of thing. Category 6, they remind us when I match it with anything else, Category 5 and so forth, it's going to perform at the Category 5 levels. And I remind you down here, things are only as strong as the weakest linked. So if I'm going to deal with Category 6, everything must be Category 6. Category 6 cabling, Category 6 patch panel, Category 6 outlet, Category 6 patch cables, the whole 9 yards. That's the only way you're going to get the performance from it. There's no mixing and matching, if you will. Category 7, a little bit different. My connectors and so forth are different. Well, as I move from Category 6 to 7, 6 is typically shielded. 7, the whole cable shielded and the individual wire pairs are shielded. So my connectors do have to be different to handle the shielding. So we have an issue now with backwards compatibility. As I move into adopting Category 7, the whole ball of wax needs to change. When you start thinking about outlet jacks and patch cables and NICs and all those kinds of things, it's like, ooh, it's going to be kind of a snowball thing to do that. This is one style of Category 7 connection. There is oops, I thought I had it elsewhere. There is another style of Category 7 connection too. One that actually looks more like an RJ connection. But there is some backwards compatibility issues. Things need to kind of adopt across the board to do that. They remind us about planning a gigabit install. Again, most of our networks are already gigabit capable because we're already running gigabit to the desktop, but Ethernet still calls for star topology, 90 meters max. Again, I'm reminding you, gigabit's pretty much going to be work area connections, so 10 gig is pretty much going to be the backbone connections. So they're just kind of reminding you here about gigabit NICs and gigabit switches and 10 gig uplinks and that kind of jazz. So for gigabit, I should be dealing with Category 5E or better. If you specify 6, remember all your components should be 6. Testing gigabit cabling, they remind us in Chapter 15 there's going to be lots of details in this, but if I go back in time, Ethernet allowed us to use 4 repeaters for connection out to a work area. Fast Ethernet allowed us 2, gigabit allows us to have 1. That's why we typically go from switch out to workstation and that's it. We normally don't put any other equipment in there. I do need to use special equipment to test for loss and other issues when I'm dealing with gigabit cabling. So I need to start testing for things like attenuation, crosstalk, impedance, and propagation delay. I need a meter, a certification meter, again we'll be dealing with this in Chapter 15, that detects or measures the amount of attenuation. I need something that measures the amount of crosstalk between the wire pairs. I need a certification meter to measure my impedance, the signal loss, impedance can cause our signal loss. And I do need something to measure my propagation delay. When I'm terminating Category 5E or gigabit, I need to have really good termination techniques. Single unpaired twisted too much can cause that link to fail. So I do need good quality workmanship for my gigabit install. When we come back, we'll do 10 gig.